Hello guys and welcome to another video. Today I will discuss with you the design patterns. Well, in this video it will be creation of design patterns and we'll do it in TypeScript. Of course, credits to this website named Refactoring Guru, which is very nice and provides cartoons as well for their illustrations. Okay, so the first design pattern is creation, rather, Singleton. What is singleton? Well, singleton means there's only one instance of a specific object or an item. For example, we have the settings object for each user. There will only be one settings for a user. Okay. Or we can also say that there will only be one um pool of one pool for database connections for all clients. So one instance of a pool, and that pool will handle everything. Okay. Now, anyway, let's see the problem described in Refactoring Guru. There we go. We have a database or a file. And what if we wanted to create a new one? For example, here down below, then you will get the one that you already created, which is an example on the left right here. If you notice, we are saying we want to get the instance of this singleton. And inside this function up here, there is an if condition wherein if the instance is null, then we create that instance. And of course, on the next call, this will exist now because there's only one reference, or this right here, this call on the highlighted line of code references to the same object up here. So that means the instance should now exist. That means this will just return the same instance, which is the singleton. Okay? And with that, we can perform methods such as, for example, a query, and we can have some kind of a method here. And then we can call that here, right? Yeah, there we go. Something like that. Okay? All right, let's move on to the text on the right side. Okay, if you notice, we have a text right here saying that it's impossible to implement with a regular constructor. What does that mean? Well, if we want to get or to get the reference of an object when we construct a class, then we need to always do something like singleton. Okay, and that's not what we want with singleton. We only want one instance, and we want also to make this strict so that um other developers that work in your code base also does not make a mistake of making a new singleton instance and working on that and wasting their time. Instead, we want to let the class itself do that for us. And to do that in TypeScript, first we want to declare private constructor so that we get the error, just like what I did earlier, whenever we do something like this. That's because this is only accessible in this regard inside of the class. Okay, this method right here, which is the constructor method. Oh, okay. And we also have the instance, and this is private and static because we only want to refer to one instance. No. Okay, so the static means that this is part of the class. So right here we have methods, right? So this class right here is almost, no, it is an object wherein each property or each method is its property. Yeah. And if you declare, for example, something static, then this will be available when you do this right here. That's why if you noticed, we can do the get instance method, but if we did the query method, we will not be able to do that. That's because the query is only available once the class has been constructed, or once the what do you call this? Once the object is created rather. Meanwhile, this is a class, and the class returns an object, if that makes sense. Okay, so what's this of singletons? Well, singleton is pretty much the same as a global object. So global object is the global context for our code. For example, the global window variable is available, as you can see, var window type global this. This is available throughout the code base. That's because this is part of JavaScript already, and yeah, it's like an abstraction layer if I'm not mistaken. So the window object is a singleton, and we have various methods for that. Okay. Now I don't see much use to this except for the fact that when we declare or when we add values to the global context, like a window, then there might be a possibility that we change it at some point of time, which is very problematic in large projects. As we can read on the right side, provide a global access point to that instance. Remember those global variables that you, alright me, used to store some essential objects? While they're very handy, they are also very unsafe since any code can potentially overwrite the contents of those variables and crash the app. There we go. And just like a global variable, so it's the same as a global context or well variable. Yeah, this lets you access anything inside of the class anywhere within the program. And it also protects this instance its data to be overwritten by any other code. So anything that's inside of the class, or rather the class can only be mutated or changed inside itself. Okay, and there will just be some methods that you can call and such. And we have a real-world analogy. The government is an excellent example of the singleton pattern. A country can have only one official government. Okay. Regardless of the personal identities of the individuals who form governments, the title, the government of an X country, is a global point of access that identifies the group of people in charge. So the group of people in charge would be the various methods that you declare. And the get instance would be what type of government is this? Or like you have access to this government now. You can contact each method or you can contact each department, something like that. Okay. It's just one entity. And this is the structure right here. The singleton class declares the static method getInstance that returns the same instance of its own class. The singleton's constructor should be hidden from the client code. Calling the getInstance method should be the only way of getting the singleton object. So that is why we declare the constructor to be private, so that we get an error by the compiler when we do that. Alright, so the pseudocode I've already shown you, so let's proceed to the next design pattern. So we have the next pattern named factory method. It is a pattern that provides an interface for creating objects in a superclass, but allows subclasses. So this pretty much means that we have a class that performs specific operations and subclasses for that superclass wherein we can do a different operation after the main operation. So in this case, if you noticed on the illustration, we have a truck and ships. So this means that the main operation or the superclass would be from the logistics. And this logistics, for example, would be to create a product. And after creating the product, the subclasses would then, for each subclass, would then handle out each of the responsibilities for that specific product that was created on the or in the superclass. Okay, so let's see the problem illustrated. Imagine that you're creating a logistics management application. The first version of your app can only handle transportation by trucks. So the bulk of your code lives inside the truck class. Okay, so all the code is inside the truck. All right. After a while, your app becomes pretty popular. Each day you receive dozens of requests from sea transportation companies to incorporate sea logistics into the app. Great news, right? But how about the code? At present, most of your code is coupled to the track plus. Adding ships into the app would require making changes to the entire code base. Moreover, if you later decide to add another type of transportation to the app, you will probably need to make all of these changes again. So what this means is that the truck class has pretty much all of the logic, and that would be the creation of the product, probably, if 'cause that's how I do it most of the time. Like all logic in one class. But yeah. And every time you add a different method, you would need to, of course, um let's say extract the logic that's the same and stuff like that. Okay. As a result, you will end up with pretty nasty code, riddled with conditionals that switch the app's behavior depending on the class of transportation objects. The factory method pattern suggests that you replace direct object construction calls using the new operator or the constructor in JavaScript with calls to a special factory method. Don't worry, the objects are still created via the new operator, but it's being called from within the factory method. Objects returned by a factory method are often referred to as products. Okay, let's see the illustration below. So we have the main guy, the logistics, with various functions, and we have a create transport wherein it creates transportation methods for both for either oh no for both the roadside and the seaside. And this inherits the create transport. And for the road, we will use trucks. And for the sea, we will use ships. So that is what we return in this function for the sea logistics and the road logistics. Okay, at first glance, this change may look pointless. We just moved the constructor call from one part of the program to another. However, consider this. Now you can override the factory method in the subclass and change the class of products being created by the method. There's a slight limitation though. Subclasses may return different types of products only if these products have a common base class or interface. Also, the factory method in the base class should have its return type declared as this interface. Okay, so in here, there's just an illustration that truck delivers by land, the ship delivers by sea, and the limitation here that they're saying is that there must be one, let's say, item, method, or data that's common within these two. So in this case, it will be deliver, the interface, transport. So both the truck and the ship is a means of transportation, hence the name transport. Okay, here we go. But of course, even if they implement this function here, they can, and well, they should in this context, do things differently. Now, the importance of this is discussed below. The code that uses the factory method, often called the client code, or the client, for example, a website, um, a web app or a mobile app, and such, doesn't see a difference between the actual products returned by various subclasses. The client treats all the products as abstract transport. That means it's currently being transported. The client knows that all transport objects are supposed to have the deliver method, but exactly how it works isn't important to the client. So that means the client can call both deliver, or rather can call deliver to any of the type of subclasses there is. For example, in transportation, we have the road transport and the sea transport. So here's another example for UI elements. Okay, so let's see. This example illustrates how the factory method can be used for creating cross-platform UI elements without coupling the client code to concrete UI classes. Okay, let's see the diagram below. We have the main class dialog that has the render function and the create button function. And we have two kinds of dialogs, one in Windows and one in web. For the Windows, we have the create button as well, and for web, we have the create button as well. For the dialog, it has the button interface. When for Windows, it returns a Windows button with the same properties here, methods rather, render and onClick, and the HTML button as well. The base dialog class uses different UI elements to render its window. Under various operating systems, these elements may look a little bit different, but they should still behave consistently. A button in Windows is still a button in Linux. When the factory method comes into play, you don't need to rewrite the logic of the dialog class for each operating system. If we declare a factory method that produces buttons inside the base dialog class, we can later create a subclass that returns Windows-style buttons from the factory method. Okay, so what this means is that we don't have to rewrite the logic for creating a dialog. We just need one instance of it. And then for each, we can have some kind of an if statement that checks is this operating system type of Windows. Then we want to return a subclass for the buttons to be equal to the Windows styled buttons or buttons that are compatible for Windows. Okay, one thing to note. For this pattern to work, the base dialog class must work with abstract buttons. So that means that these buttons um, can implement their own methods. A base class or an interface that all concrete buttons follow. There we go. This way, the code within dialog remains functional, whichever type of buttons it works with. Of course, you can do this not just with buttons, but also with other UI elements such as links. But with that method, we are getting closer to the abstract factory pattern. And we will talk about that right after the factory method. Okay, so let's see here. We have the dialog class and the method create button, okay, which returns a button, and the method render. The button will be equal to the function return or the value returned by the create button method, and we will render the button. Okay. Then we have two types of dialogues, as what was laid out by the diagram earlier. We have the Windows type and the web type. And for the Windows type, we will return a Windows button. And for the web type, we will return an HTML button. Okay, so we will declare the Windows button below, which is here, and we just inherit or we just implement the methods or functionalities of a normal button, which is up here. Okay, and now we have the client, or in this case, the application. So we just need to check the environment or the configuration in this case, if it's a Windows app or a web app. And of course, in either of them, we declare a specific type of dialog for each of them. Okay. So for example, it has a different style. For HTML, has a different color. For Windows, a different color, etc., etc. Okay, let's try to run the code on the left. So we just have a simple creator wherein we can perform the main operation for this class and of course the factory method wherein we can have different kinds of methods inside of this creator. And one of those methods, for example, is the class named concrete creator, and this will return a specific kind of class, in this case a product. And this product will have the operation right here, wherein it will perform its own operation. In this case, it just returns a string. Okay, and with this method, the client doesn't really need to know anything. It just needs to run whatever we pass inside of it. So if we try to run this, there we go, and wait for it, voila. As you can see, we got client. I don't know, I still work, but I don't know what type of operation I'm calling because this right here is the main factory, and these two right here has the same methods as what the creator has, the factory method and the operation method. Mhm. Okay, so where was I? Okay, I think I was in the middle of discussing the code on the left. Okay, let's see. So we have an abstract class named creator. We have the method, factory method, and the operation. So what does this do? Excuse me. Well, this will give us the ability to get whatever operation there is available inside of a subclass. So in this case, the method named operation. Okay, and since the interface product is equals has the method operation, that should be what these factory methods should return in this case. So we have here down here, the factory method for the concrete creator is equals to this right here. It will return the concrete product, or it will return the constructed object constructed by the concrete product, which is down here, and it has the method operation. All right. Let's see. Mhm. Okay, so let's see the code below. We have the client. So this client doesn't really need to know what is being passed onto its parameter. It just knows that it's calling a factory or a class named creator, which is a factory. And once it's passed here, we will want to call its method named operation. Now, what does the operation do? Well, it calls the factory method. So in this case, we pass on the constructed class named concrete creator, which then its method was called up here. So that means this constructed class concrete product is returned or is assigned to this variable named product. So that means this product now is equals to the constructed object of the class concrete product. So we have access to the method operation. So when we call this up here, as you can see, this will be returned, the result of concrete creator. So in here, we can do something like, for example, in our example, we do some kind of operations to create a product, manufacture it, yada yada. And then once that's done, we will get all the available, let's say, transportation methods, which is what we call factory method in this case, and then assign that to a variable. And then we want to call, or we want those transportation methods to actually operate. So in this case, we will call operation. And if we want, we can also pass in the created product or something inside of them, the operation methods as a parameter, if you want to. Okay. And how was that possible? Well, because of the keyword extends. That means that this class named Concrete Creator wants to inherit all the properties and the methods of the creator class. Okay. So that means we actually don't want, or rather, we can like have it not declare the properties such as operation because we would be extending this one up here. That's why we were able to call this down here. And this referenced, or rather this referenced, yeah, correct, this method right here. Okay. Okay. Very good. And of course, when we declare the method inside of the class that inherited something, well, this will override it. And here we have no value, and here we have a value. Okay, let's proceed to the abstract design pattern. Okay, so we have abstract design pattern. So abstract is related to factory design pattern or the design pattern named factory. That's because in abstract, we have a relationship between each classes. Is that right? Yeah, family of related. Yeah, a relationship between a family of objects, wherein, for example, they have the same characteristics and such. Okay, and if you notice the illustration, which is very good, by the way, we have the spheric factory, or like all items is in the form of a sphere of a sphere. Abstract factory, all items are abstract or like all have the same characteristics, for example a chair, but they have different styles and such. Pyramidal, all is triangular. Okay, so let's say we have a problem. Imagine that you're creating a furniture shop simulator. Your code consists of classes that represent one, a family of related products, say chair, sofa, and coffee table. Several variants of this family, for example, products, chair, sofa, and coffee table, are available in these variants: modern, Victorian, Art Deco, Deco. Okay. You need a way to create individual furniture objects so that they match other objects of the same family. Customers get quite mad when they receive non-matching furniture. So that means we have different furniture classes, and in those classes we have a method for each type of furniture with that would be chair, sofa, and coffee table. And of course, that class, for example, would be modern, Art Deco, and Victorian. So modern furniture, Victorian furniture, and modern furniture. Okay. So what is the use of this? Well, as you can see here, they are different because we did not implement the abstract design pattern. And this is useful, for example, I think, in searching for stuff. For example, a user recently bought an item in our shop and we want to show them recommendations. Well, those recommendations, we will check its category, and based on that category, we will show a list of all products within that category. And I think we can use the abstract factory for that. Okay, let's proceed. So the solution for the problem above is to explicitly declare interfaces for each distinct product of the product family. Okay. Then you can make all variants of products follow those interfaces. For example, all chair variants can implement the chair interface. All coffee table variants can implement the coffee table interface, and so on. They both have legs. Okay. The next move is to declare the abstract factory, an interface with a list of creation methods for all products that are part of the product family. Okay. So for each furniture, we have three methods. For example, we have create chair, create a sofa, and create a coffee table. These methods must return abstract product types, represented by the interfaces we extracted previously, the chair, the sofa, and the table. Okay. Okay. So in here is pretty much saying that if a class in an abstract factory already does something, it should only do that thing. For example, if it's something that deals with modern stuff, in this case furnitures, it should only do stuff with that is related with modern furnitures. Okay. So for example, in the client code, the user requests for modern, we will show them all modern furnitures. Okay, without breaking the client code, because we don't need the client code to like handle everything. We need it to be dynamic as much as possible. Include support both factories approaches via respective. I think I forgot to pause the video. Oh no. Okay, anyway, let's proceed to what I was thinking. So in here we're saying that the client doesn't care what type it's trying to use. So if we refer to the code on the left side, it's exactly just that. We don't know, is this like modern or is this vintage, as you can see here? We don't. Okay. And the thing that called us, or for example, the server that sent this or something, is the one that decides what we get. All we need to do is to, well, create a chair, for example, or create a sofa. and the type of that is dependent on what is provided to us right here. Okay, yeah, all this cares about is that, okay, this is a chair. I don't know which type it is, but it's a chair. Okay, this is a sofa. I don't know which type it is, but it's a sofa. Something like that. So let's try to run this. Let's run abstract. There we go. Okay, let's wait for it. Voila. We are testing modern furnitures, and here we go. Created modern chair, and that would be this call right here. And we have the second call, created modern chair and created modern sofa. So if you check the mix, it's pretty much just adding the two of them together. Where is it? Right here. So once we call the method for the chair, for example, we will call the operation for the variant we passed onto it. And that would be for the chair right here. Okay, and for the all the other furnitures as well. So I guess with what I made, I can just have a single glass toy and then just extend it. Yeah, with this kind of templating. So just I can make this dynamic, pass it on. Yeah, with using the super once it's inherited. Yeah, constructor. Okay, I'm just thinking to myself, let us proceed. So we also have the vintage, and as you can see, it's pretty much just created various chairs, sofas, and beds based on their type or category. In this case, modern and vintage. And it doesn't care about which type it was, or it didn't care, rather. Okay, let's look at the structure for the last part. Okay, the very first one would be the concrete factory, and that would be this one. Create modern furniture and create vintage furniture. Right? Let's see. So we have the create product. Yes, we are creating a product here. And we have the abstract factory, which should be. Oh, so there's. Oh, okay. So it's just an interface. Okay. Okay, so they're the same. Yeah. It just implements it. Okay, good. And then this factory has references to, for example, the vintage share. And this implements the abstract of whatever the abstract is. In this case, the abstract in our example is furniture. And this returns so in this case, okay, so this one here returns the one below is what I'm doing with the mix function here. Okay, yeah. uh-huh. So products group by variance, abstract product must be implemented in all given variants. Okay, so that's exactly what we did. So for each variant, that would be, oh, is it more variant or abstract? For each abstract, that would be the category of modern and vintage. We implemented all of the possible furnitures, and that would be modern. That would be chair, sofa, and bed. And those methods are mix and operation. Okay. An abstract factory declares a set of methods for creating, and that would be here, this right here. We have create chair, create sofa, and create bed. Okay. And the concrete factories implement creation methods of the abstract factory. Okay. So we have this. This is the concrete, and this is the abstract. All right. Yeah. As you can see, it just refers to chair. It doesn't know what type it is. All right. But for the concrete, it clearly knows what type it is. Okay. to turn corresponding abstract products. Factory doesn't get coupled to the specific variant of the product it gets. Can work with any concrete factories as product variant. The pro objects via abstract interfaces. Yeah, okay. Mm. Oh yeah, yeah. This is okay. I did this somewhat wrong in when it comes to types. This should be bad. There you go. Just to make it like explicit, but it's still the same. Just you know, should be like this. So now it's looking more like what is in the explanation on the right. So the vintage share doesn't care what kind of abstract it is. It just well implements a chair. Okay, and this category is vintage. All right. What else is this? So far, soda. So far, not soda. And we have a chair. All right. Okay, I think that is it. Yeah, very nice. Oof. Those are the three design patterns for now. And I just decided to study them and, record a video about it. It's pretty nice though. It's actually because I like learned about, like even though I've been doing it in React about observer pattern. And, I decided, oh, why don't I try to read more about this? And yeah. I will see you in the next video with me discussing more about this, guys. This design patterns, and I might include structural next. After, of course, finishing the creational ones. And then after that, I think I might go to make a guide about JavaScript, like a proper one, discussing the various methods like post increment, pre increment, data types, types arrays, and yada yada. Okay. Anyway, thank you for watching and good luck on your development journey. Happy learning.